Number 14, moving on to some longer free response questions. Describe how a covalent bond holds two atoms together. Let's go back to a little diagram we have here. We have atom A and we have atom B. Get this out of here. How does a covalent bond hold two atoms together? So here are two atoms, A and B. A covalent bond is going to exist when we have two electrons shared between the two atoms. Now there's going to be an electrostatic attraction here. That's what a chemical bond is, a mutual electrical attraction. We need to remember that present in each of these atoms is a positively charged nucleus. And so there is going to be an attraction between the negatively charged electrons involved in the bond and the positively charged nucleus of atom A. At the exact same time, there is an electrostatic attraction between the electrons negatively charged involved in the bond and the positively charged nucleus of atom B. And so they're both very strongly, I might add, being attracted to the two electrons in this bond. Now because of that, anywhere that this atom moves, this atom is going to follow because it's being attracted to these two electrons in the bond. And so when we're going to describe this using language, a pair of electrons is attracted to both nuclei of the two atoms bonded together. Simple as that. Okay. It's a English transliteration of this beautiful diagram that we have here. Number 15, what property of the two atoms in a covalent bond determines whether or not the bond will be polar? By now, you guys should be very used to finding your electronegativity differences in electronegativity. That's what you're going to look for to figure out what type of bond it's going to be. 16. How can electronegativity be used to distinguish between an ionic bond and a covalent bond? Well, here we go. We have our different ranges. Again, we've gone over this, try to hit this pretty hard. This is where you start to use that. You're going to find, let's use the word calculate. It's a better word. Calculate electronegativity differences. Okay, first step. If, well, I need to capitalize that. If the difference is less than 1.7, less than 1.7, that's going to be a covalent bond. If the difference is greater than 1.7, the bond is ionic. Simple as that. Electronegativity differences, interpreting the results of your calculation. That's what we're doing here. And then number 17. Describe the electron distribution in a polar covalent bond, and its effect on partial charges of the compound. Now, when we have distribution like this, it's right smack dab in the middle, okay, we call this a non-polar covalent bond. But 17 is asking about a polar covalent bond. So we're not going to have the electrons right smack dab in the middle. They're going to be closer to one atom than the other. The first thing that this question is asking us is to describe the electron distribution. How are these electrons distributed? Now, to answer this really, really well and super chemistry-like, I'm going to use a term that we haven't used in class yet, but I'm going to start using it. It's called electron density. The electron density is greater around the more electronegative atom. All right, so we're doing the first part of this question. Describe the electron distribution. It's more dense. There's more electrons. There's more chance that the electron is going to be closer to the more electronegative atom than the less electronegative atom. So that's the electron distribution. They're going to be closer to one atom or the other, and which atom it is completely depends on which one is more electronegative. The second part is and its effect on the partial charges of the compound. Okay. Now, the electron density is greater around the more electronegative atom. So this makes the more electronegative atom partially negatively charged, and the other partially positively charged. Now, these are going to be equal charges. It's not like the partial negative charge is going to be greater than the partial positive charge. The magnitude of the charges are the exact same. They're just opposite in direction.